if you want to understand the basic understanding of the architecture, we need to go deep uh, in understanding how does it work. Let me just show you the architecture of a transformer. Okay. Let me just open this only for now. But there was a paper that was published in 2019, I guess. So all this is research based. Firstly, like academics do research over it, and then um, it get to the real world, like in the industry use. For an just to give you a reference, the first computer vision model for object detection was released in 2016, the Euro model, and that is used in the industry now in that extent. Right now, in the computer vision domain, we the state of the art is the quantum understanding. So, yesterday or the past week, Meta released a paper which was like some pattern recognition kind of a thing, in which it was making um, a huge data set around 8.7K unique classes to for the robot to understand. A different topic. I will just tell you about it. So, all those research kind of thing happen way too earlier, and then it get involved in the industry at after a validation is achieved. So, like transformer was introduced and attention is all we need by a paper in Google, I guess. So some Google researcher published this. Attention is all you need. This is a very important. It is like the first step for an AI engineer to go through. Right? But since it will be so much uh, deep knowledge to understand this, we will not be going through it. But if you have interest, you can go and read this paper, and then we can come up with what it was providing. So transformer, the attention is all you need. This is a paper. Uh, yeah, we can find it in our Excel. Yeah, see, here it is. So I will send it to you. Don't worry. I will send other things. So this is the paper. It was using a like these were the people in Google research. They published this particular thing. So see, this is the architecture which transformer follows. Now you see, we have softmax. This is the output layer. Then we have input embeddings. This is the input layer. And then in between, all those are the hidden layer in which the operation is handling. So there are different type of layers which perform different type of applications, which are used for different things. So if you want to consider, my iPad is not working, or I would have written it and showed you. Yeah. So if you in the normal model architecture, so we have input layers which, pardon for my spelling, then we have some hidden layer, and then we have final output layer. What does layer mean? You are able to understand, or I should give a brief description of that as well? Yeah, it's type of processing in with the data. So like let's say I have a very small. So this is like a very big thing in transformer. Let me start with a basic model. Let's say I have a model uh, MLP. Okay. MLP is multi-layer perceptron. So this is a very simple model. See, this is a very special model. Where is my cursor? Yeah. See, let me open the images correctly. So this is better way of interacting. I like it. See, there are some thing that goes into the input layer. Input layer is considered as a basic thing where we give the information to. It goes with transform based on the pattern, understand the pattern, let's say to the classification model, right? So it will have some output. So it will go transform, understand the pattern, it reduce the thing, reduce the size, and then it will give a particular output. This is normal architecture based on the training. Perfect. I really like because you know very things in detail. There is so much thing in open system. I cannot share my full screen. But let me add in the agenda for tomorrow so that I can show you. Uh, at, date 11. So, okay, so I will show you how training is done for a normal MLP architecture tomorrow. So let's say it can be a simple model, a deep learning model to classify between dog or cat. Or like, let's say we will be doing more simpler thing of doing sentiment analysis. Okay, that can also be done. Now, this is the
So
basic
Ayush,
basic idea.
just to understand that tomorrow you will show me how to train a model that is going to we will be feeding some text to it, and it will do sentiment analysis and tell us if it is happy, sad, angry.
Yes, yes,
or-
yes,
Okay,
yes, yes.
okay,
So that,
okay.
that then you can understand how NLP works. So basically, yeah, what is the exposure with Python? How well do you know it?
Python, I just did some basic courses. As I said, I'm basically working with C sharp for many years now. Python, I'm relatively new, but I can follow along. I did a couple of courses to understand the basics. Running Python code in Jupyter notebooks to understand. So I
Got a
should
point,
be
got a
okay.
point.
Yeah, yeah. You can. I should be able to follow along. So that should be fine. If I have any questions, I'll ask you as we go.
Perfect. So, so yeah, I guess because if I need to show you what is the actual way of going through GenAI is this. You need to understand first the Python. In Python, there are a lot of things to understand, but at least you should uh, get going with the normal basic stuff like list, set, filter, lambda function. Then I guess you can be able to do it in a way that you are able to get some data and then fetch it using libraries, packages, importing them. So those are the basic steps. I guess you can just grasp it. It is not that tough. Then comes the thing of ML. Now in ML, not like I wanna make you learn about random forest or other thing. Random forest. Um, so see, let me just give you a crisp description of what ML is, okay? And then I guess it can also be better for you to understand. So in what machine learning is, so everything in the AI domain revolve around data and output, right? So machine learning is a part of AI in which we do give some sort of sample data, some data to the model. The model try to understand the underlying pattern, and then we can use that model to predict some unseen data. So there are two type of basically there are three type of ML. One is like uh, supervised machine learning.
Fine. Yeah, supervised,
Yeah,
unsupervised. Yeah,
perfect. You know about them.
yeah.
Supervised, another is unsupervised, third is like reinforcement. Semi-supervised, my bad. Okay,
Semi-supervised. Yeah. Okay. Yeah,
okay,
that's good. I've done a bit of work on this in Azure. The regression modeling where we estimate the prices of houses and cars
right,
used
right,
cars.
right.
So I've done a bit, and
Perfect,
then some
perfect.
classification, some categorization. So I've done some work there in the Azure space. Yeah.
Yeah, so we have classification and supervised, and then we have regression. Okay,
Yeah.
okay. Now the thing is, just make a spelling. Okay. So the thing is in supervised and unsupervised, we do follow some model. We do implement it using some models. Do you know any idea about those models?
Yeah, we used just the algorithms, because Azure is a little, low code environment. So
Yeah.
I didn't use the models. We just, choose regression model and go with it. So
You're
yeah,
right. So the underlying way to implement classification are random forest. So these are the algorithms. We do have SVM, we do have K-means. There are many. There are many algorithms, right? And then
Okay.
these were some basic. Now we have some advanced version of those as well. Uh, so we have XGBoost, we have Cat Boost, right?
Right.
We have ADA Boost. So these are some boosting algorithm. Now these are some important thing. These algorithms sometimes overperform some deep learning algorithms in structured data. So like if the data is very much structured in sense, we have some input, we have some output, it is in tabular format, then uh, sometimes simple machine learning models work so fine. So there is
Right.
nowadays what is happening in the industry, everyone wanna solve each and every problem using AI. It could be
Exactly.
solved using classical machine learning as well. Some person are trying to classify the document using AI. They can just use like let's say a very vague example. So let's say if I'm getting some document and the summary of the document is written over the name of the document itself, right? But some engineer is trying to do. Just give me a sec. So some engineer is trying to import, open the document, import all the things, and then summarizing the information a long way around. But it can easily solved using the name of the file, taking them, tokenizing it, sending it to a simple random forest, and then classifying it. So that can work better. Right? Just a vague example. If you don't understand it, don't give much
No, no, I
thought on it.
understand that. Yeah, that
Yeah.
a simple model can be used in the case of a simple problem.
Simple problem, right? But uh, yeah. So long story short, we have random forest. So random forest is like a tree based. We have decision tree. Okay. These are the classes. These are the models. Let's say algorithms. For the classification application.
Right.
Today, like if you got time uh, tomorrow, whenever you got time, just go through them once. You will get some idea. So what happen is we provide some data to this algorithm, then they understand based on how they perform, and then they give the output. They get trained, they understand the underlying pattern, they get trained, right? So very
Right.
very simple, very basic stuff they follow. Now there's some problem that can be solved using this, like some time series forecasting, some um, um, normal NLP. There's some other anomaly detection. Those were solved using classical ML only, predictive maintenance kind of a thing. Uh, yeah, those all application, those all domain are solved using classical machine learning techniques. Then we do have regression. In regression, we do not in the output we do not give any particular class, as in a whole class like dog, cat, yes, dog, cat, yes, no, another classes. We give a number, a numerical value, right? And
Right.
then in unsupervised, we do clustering. We don't have a data which is very much like a structured data, but it is not annotated, as in it is not labeled. You know the difference, right?
Yeah, yeah. I've covered that. Yeah.
Yeah, perfect.
Categorizing like categorizing various various categories, putting
Yeah,
data
right,
or results
right.
into categories. Yeah, that's fine. Yeah.
Right. So in unsupervised learning, we have some other algorithms like k nearest neighbor. So we have a lot more, but yeah, we can cover. We don't need to cover. I'm just giving you some information so that you must know about all those words.
You need to
In
Ayush, just
semi-supervised,
write that over here, like in unsupervised, just write the name. So, I can maybe whenever I have time tomorrow or, I
yeah.
can do a basic read up on it.
Okay.
Yeah. K nearest neighbor. Okay, that sounds
Yeah,
good.
this is k nearest neighbor. Uh, we can also use, I guess, k-mean. There was some model of k-means that we were using. We can also use logistic for some time. Right. So, in semi-supervised, the point is, we do not like we use some sort of, it is not exactly we are using a model for it. It is like we are getting some data. We are using the unsupervised to uh, do a category, and then business category we label that. So it is kind of that model.
Okay.
So what do we do? Like, let's say if I have some sentiment analysis model, right? I need to train that. Now, I can just use some of the data to like some of the label data to train a single model, and then use that model uh, to annotate some more data. So it can be used as a code training
Okay,
to
got it.
analyze. Right. Or
Yeah.
let's say if I have like my use case is to classify some images based on some category. So what I can do, like I can train a model to classify the images into categories of some small amount of label data. Like let's say I have 100K or 10K images. So I will just take 100 images and then use a model to train it, and then I will use that model to go to the unsupervised model, like unseen data. It will act as a unsupervised model to bring up the categories, and then can get the more data for retraining.
Okay, got
So
it. Yeah,
this is like two-way approach, right?
yeah, yeah.
So
I understand.
key concept in semi-supervised are, we do cluster assumption, we do self-training, and we do multi-view training. Like these are three things we do have. Let me just write it over here. So we have some cluster, then we have multi-view training, and then we have self-training. Now, after this, the thing that comes is deep learning. So deep learning starts with normal architectures, not normal, those are some complex, and though like I cannot explain in a very simple manner, so I will have to take a deep dive. So maybe we can have a dedicated session for that tomorrow, but let me just try it over here. So in deep learning, there are different architecture that are very generally followed here. We start with uh, I don't remember the name. Single layer perceptron. I guess this is the name. I don't remember. It is so long. I have like this is not used in industry so often. Single layer perceptron. Then we have MLP that I was showing over here. MLP. Then we do have I don't know. Backpropagation is a task, or it is let me just. Yeah, backpropagation is kind of a concept which is followed in those models in MLP. Then we have
So that
RNN. Then we do
I
have
the basic
LSTM.
understanding of that, yeah.
Yeah, we have RNN, we have LSTM. We have a lot more. Let me just give it a thought. Okay.
So if I understand correctly, if our
Yeah.
requirement is simple machine learning, doing something to simple machine learning, then we can use this supervised, unsupervised, semi-supervised, and we should be.
Yes.
But when we go into deep learning and we want to create a transformer or how a transformer is made, that is using these deep learning uh, model algorithms. And these are the
Right.
algorithms: SLP, MLP, RNN, LSTM, CNN. CNN, I think,
Right.
is
For
for
computer vision.
images, right?
Yeah, for images. CNN for images. So
Yeah.
these are the top um, thing we do use. Now, then we have some Gen AI or some advanced deep learning. So in there we do have autoencoders, we have encoder decoder, we have transformer. These are the things we do have here.
Wonderful. Okay, wonderful. This really explains it very well. So one
Okay,
question
so
before we go further, during the course when we are going to be using like prompt engineering and then we will use RAG and some fine tuning, that will be at a higher abstraction level, right? We will not be
yes, this those are the final point. Like fine tuning is the topmost thing that is done in LLM thing. Fine tuning is not very simple and like since we do have code for everything, hence it is simple. But the underlying theory beneath it, like it is not very simple. So
okay.
I will just give you some practical implementation. So like a go through code kind of a thing, so that you will
Yeah.
be understanding this is like I am doing fine tuning, but making an like let me just type that as well. So then we do have in LLM space, right? In LLM, what concepts we do have? We have uh, pre-trained open source model. Okay. Then we have some RAG. In RAG, we also have types nowadays. It's been ages like since normal retrieval augmented generation was released. Now we have graph RAG, we have multi-view RAG, multi-agent RAG, 14, 15 type of RAG I've seen. But yeah, we will be going with simple one only. And
I
then
will
we
cover the
have
simple one.
different type of LLMs on here. Like we have some instruct based LLM which are used for conversation kind of thing. We have some summary kind of LLMs which are just used for generating the summary. So for every particular use case, we can use a LLM for that, right? So it is based on large language model. So we can just train our own model for a particular use case. We can just use classification LLM as well. So like there was one study I was doing um, for my use case. So it was like there are some vet notes, like vet doctor. They create some notes. So a particular research was done in MLU, I guess. Uh, CMU and MIT, if I'm not sure, wrong. So for a good 2 years, they annotated those vet notes to a particular disease. So like they annotated them into 9 classes, and then they have used LLM for the use of um, classification. So if you just provide a wet note to it, it will just classify whether it is what disease or what disease it can be based on the descriptive diagnosis and all. So it can view a simple um, ML problem, but the like why we were using LLM because it was able to understand more um, pattern of that beneath the data. So like we have a lot of text. Now understanding what does it mean, getting insight of all those things, a language model is required, right? So we can use LLM for classification task as well, long story short. You got my point?
Yeah, that sounds good. So during this course, we will also be uh, using some open source model, and
Yes,
then we
yes,
will
we
be
will be.
working with it with RAG and fine tuning and everything, right?
Yes, 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 yes.
Okay, perfect. That's
Reg, I guess, yeah, I've shown LLM, we have fine tuning.
there was also some one topic of
There
text
is.
chunking. Text chunking. What is that? That I didn't really understand. Chunking
So
the text. That is part of fine tuning.
no, so like that is a part of a RAG. So when you will be saving some data, no, I will tell you, I will be coming over that.
Okay,
So
that's fine.
these
So
are
that's
some,
part of RAG.
yeah, so these are the fine-tuning techniques that we will be going through. Now, what does, okay, yeah, I haven't gone through a particular concept. Let me just start chunking embedding only. So, when we try to let's go with this, then you will understand it better. So whenever we are trying to train any machine learning model or any deep learning model, we need to convert all the textual data to numbers because machine understand numbers. Okay,
Right,
so we convert our text to embeddings.
right.
So there are different way we do that. Let me just type that here. Okay. Okay. So, what are EMB? I will go. Let's say if your name is Munib, I can just my bad, sorry. I can just rewrite it as a list array with um 0, 1, 1 something any embedding. It is based on the data only, right? There are
Right.
different type of method we follow to convert those text to number.
Mhm.
Now, let's say I have a good amount of data, you are looking good, or let's say a sentiment analysis model for now. Okay. Now, in sentiment analysis, what kind of data I would be having? The movie was pathetic, etc., etc. Right? It will be a bad review. I like the actor. It is a good review. Now, based on all those, we can get all the data, we can annotate like this is all going in the algorithm only, right? Not in the machine learning algorithm or the training part. It is some other algorithm in which we are doing chunking or embedding. Okay, so this is the other part to facilitate or to give the upper hand to the to that model to understand, right? So we will be getting all those data, we will be collecting them in a place, we will be assigning the whenever die is coming, it will be zero, movie one. So it is a bag of word approach. Bag of words, we will be giving a number to each word, and then we will be converting this to array. So like let's say da was zero. Okay. Da is like zero, movie is like one, was is like two, pathetic is like three, I is 4.
So this
Okay.
is like converting the text to embeddings.
Yeah. Actor is like, this is very basic, I'm telling you. There is a lot more. So it will be coming like 0, 1, 2, 3. Here it will be coming like what?
Four,
4, 5, 0, 6.
six.
Right? Now there is another concept here. See, the, is, I are the stop words. What stop words are? So, these are some important thing, right? I am telling you like without giving much emphasis. Bag of words. These are the legit concepts, okay?
Hmm.
Like since you wanna learn, I'm not giving much emphasis, but these are some legit concepts. People ask in interviews, what are the stop words? How to remove stop words? What is the bag of word approach? Right? So we need to remove the stop words before giving this to the model because then we will be having more thing which are irrelevant, like some is the uh, of certain words which are which cannot be used directly for the um, sentiment analysis task. Our main word is what? Pathetic. Like maybe actor, movie can also be a good like the word which we need, but the, was, I, the are the stop words here, right? Got my
Okay,
point?
got it. Yeah. Totally
Right?
makes sense. Yeah, makes
Yeah,
sense.
we need to remove this. Now, this is what was very easy example of text embedding. We do use transformers. Oh, sorry, we do use TF-IDF for it. TF-IDF is what? So TF-IDF is term frequency inverse document frequency. It is a concept. It is a algorithm kind of a thing which we apply to embed all those text into numbers. This is the most popular in ML. So how does it perform? It is like uh, a particular word is coming how many time divided by how many time it is coming in the whole document, and then it is giving a word. So term frequency inverse document frequency. Very crisply, I told you what there is a lot more difficulty in understanding the underlying mathematics behind it. You don't need to. You just need to understand TF-IDF. Got my point?
Got it. Yeah, sounds good.
Okay, perfect. So this is what? This is embedding. Now there is some way how do we perform embedding? We can perform embedding on the whole paragraph, but it will it make sense? No. I will not be able to gather much information with paragraph. I can gather more information with sentence. It is totally depend on what kind of use case we do have. So this is chunking. What chunk means? A particular block of anything, right? So let's
Right.
say I perform sentence chunk. I am chunking my whole document in sentences. I am chunking my whole document in paragraph. I'm chunking my whole document in words.
So Ayush,
Now,
when we say creating embeddings, this is
yeah,
creating embeddings of the input that we are providing, right?
yes.
Okay.
Now those chunking, right? Chunking we do perform in normal machine learning deep learning case as well, but in um, generative AI, where chunking is used. Chunking is basically used at a point when drag is implemented. We want to get a view when we need to divide our data. Whether we want to divide in sentence level and store it into vector DB, then it will make more sense. What kind of chunking method we want to apply? Let me check if I have done it over. So it is not a specifically done based. Chunking can be done based on sentence, based on words. Okay, based on whole paragraph, but it is very many much time more uh, specified. Okay, spelling is wrong. Uh, N level. What does N level means? Like 300 characters, something like that.
Yeah. A specific subset.
Specific here. Okay. Now we do chunking and then we split the data uh, to to make it more readable, understandable for the LLM and then save it to vector DB. Let me quickly show you something. You are gonna like it. How to share it again? Okay. Desktop one. I hope you can see my whole screen.
Yeah, I can see it.
Perfect. So I was working on um uh, a RAG application. So here, see, embedding. Okay.
Right.
And then let's say, let me just give you a quick, like, okay, this can be our last topic in today's session. So what I have done, I was I've created a normal chatbot using OpenAI's model, but I have included RAG on the OpenAI GPT-4 mini model. So I can just use GPT-4 mini from ChatGPT, or I can just call it anywhere. Like I could have called it here as well. See, I'm using GPT-4 mini from ChatGPT, OpenAI, and then I am giving it a custom prompt. Okay,
Right.
so this is the custom prompt I'm giving. I can just have some sort of prompt engineering over here, tell it some more or other thing, and then I can have a chat with it. But I want to provide a data source to it. So to
Right.
providing data source, I'm implementing a RAG pipeline. I have taken some data. I have initialized an embedding model. What kind of embedding model I will be using here? So TF-IDF, backward, sequence to sequence model. These are some basic stuff. Here we do use some large language model only to embedding as well. So text embedding 3 large is the model we are used for embedding, because it is like a pre-trained model of many many on a many bigger corpus of data, right? And then I am using Chroma DB to store all of the things. I am using Chroma DB, and then I'm
Is your
loading my
vector
PD,
database, right?
yeah, for the vector database.
No.
And then I'm say using a library PyPDF to load my data. Here, chunking is happening. Like we are splitting it to the document. Now we are using recursive character text splitter. Why I'm using this? Because let's say, Munir, I am if I like see chunk size is 300 words, right? So
Mhm.
these 300 words basically mean what? I will be having some sort of yeah, okay, I need some paragraph. Let's say I have this. So if I need to let's say this is the chunk size. I'm getting this and then again I'm getting this. So uh the underlying what it is trying to show, like what does it a particular chunk mean, the idea will be gone, because sometimes reading a full sentence can give us what it is trying to say. Sometimes a sentence is connected to another sentence. Like many times it happens, we like there is a word which whose meaning we don't know, but we try to read it through the sentence perspective, and then we guess what does it mean, right? You got my idea?
Yeah, yeah, I get it.
Right,
That sounds
right,
good.
right. So if we are performing a chunk, it will be a problem. Why? Because it can mean something else. So what we are doing it over here, we are overlapping the chunk so that we
No,
know the previous context as well. We are doing chunk, but every time we are overlapping. So it is kind of a sliding window. So let's say for the first chunk, we provide it up to here. For the second chunk, we overlap this part and then we provide it up to here. Third, we again overlapped. So this
no,
is
no,
the
that sounds
overlapping,
perfect. Yeah.
right? And then we are so there are other functions. So we can just use this. We can just do some separator as well. So like let's say if I know this is my own data, I can just separate it using colon. Colon is like of end of a paragraph. So yeah, very big very big thing. And not very big thing. I mean, you just need to experiment it. But yeah, we have a lot of thing here. And then we are creating the chunk. We are saving it into vector DB. This is what chunking means. This is the main application where this is becoming. So you must be thinking why I'm using embedding model over here.
Right. So this is to sort of define the type of embedding that we are going to create, right?
Right. So now we will not be using embedding to ingest into the data, but since the data we will be using like we will be chatting with this LLM, we will be providing some data as an input. So that data should also be embedded and then need to go into the DB to check for the matching. So how RAG perform? So basically, whatever input we do have, it goes to the vector. It performs KNN, not exactly KNN, but yeah, any similarity approach it to perform, and then it check the um, the output the text which is very much aligned with what the user is asking. That whole thing is done using LLM and drag. So we are using embedding model again here because every data that is passed to the model should be encoded. Encoded
Okay,
in a
got
sense,
it.
it should, right? So we are using embedding again, and then in this, and yeah, we are using LangChain over here. There are two type of framework very frequently used, LangChain and LangIndex. So this is
Right.
using LangChain. I can show it, like the working is simple, so no need to show, but yeah. And then we are performing prompt engineering as well, and then we are starting a stream of those prompt and then going with the message kind of a thing.
I think, Ayush, this is the model we can follow during our learning. Like you have used, I think, OpenAI model. We can use
Yeah,
this one with some other open source model, download it, and then you can just,
yeah,
all these steps, we can go one by one and, we can cover them, and that would be perfect.
yeah. I have other models as well if you want to see it. I can show that to you tomorrow, no issues. So there is a framework called as Olama. So you can just install Olama into your machine and then you can use those open source model in your machine directly.
Yeah, I think
Okay.
that would be a good approach. We can use Olama and get a model, and
Yeah.
then we can work with that model. We can do the prompt engineering, the RAG, the chunking,
Yeah.
and then do a little bit of lang chain, little bit of fine tuning, and I think that would cover our whole syllabus.
Right. Now, coming over the next course of what we will be doing. So like tomorrow, we will be going with normal NLP. Okay, normal stuff that I showed you today, no, that we will be showing doing so that you can have an idea of the process how it is done. Uh, I will not take much time over here. I will just have the code ready if I can, and then I can just share that with to you, and then you can give it a look. Normal, let's say we'll be going with mm,
Sentiment?
sentiment analysis. Okay, going with sentiment
Perfect.
analysis only. My idea is for ML, but I will try for DL as well. Okay.
Perfect. Perfect.